Okay, so let me here in closing give a couple of examples of some problems with some particular radioisotopes. First of all, iodine 131. Iodine 131 itself is a beta emitter. It has a half-life of 8 days. And the problem with iodine 131 is that it is a fission product. So it's going to it is a product of nuclear fission reactions. So it's found in nuclear fuel cells and then the waste nuclear fuel cells that are still stored on site. It itself is water soluble, and iodine is a micronutrient that is needed for hormones in your thyroid gland. And so it collects iodine in your body. Once it's in your body, it collects in the thyroid gland. So the problem is that if iodine 131 accidentally gets into the environment, say from a nuclear power plant, it will dissolve in water, so it can get in the groundwater, and then it can be, if you happen to drink the water or you eat something else that has drank the water and now has that iodine in it, then you could be exposed to this iodine 131, and it will collect in your thyroid gland. In small amounts of iodine 131 can actually lead to thyroid cancer, whereas high concentrations of iodine 131 are actually used for medicinal uses to treat thyroid cancer. Okay, see, in the high doses, because it's a beta emitter, it will just kill the tissue around it, and it will be just right in the thyroid. It doesn't penetrate very far, and since it's in the thyroid, it kills the thyroid tissue. It's actually a great treatment for thyroid cancer. But in small doses, it just does enough damage then to the thyroid cells that could then lead to mutant cells, which then leads to cancer. And so people who have been exposed to iodine 131, for example, from nuclear accidents, for example, Chernobyl, have been shown to have a greater incidence of thyroid cancer. So it's a good and a bad thing. And then radon 222, I promised I'd come back to that one. Radon 222 is an alpha emitter, and it has a half-life of only 4 days. It's a noble gas. So what happens with radon 222, since it is a decay product of uranium 238, and uranium 238 has a half-life of 4.6 billion years, although uranium is a very slow decay process. So that's why we still, even though the Earth is so old, we still have uranium 238 around, which is constantly undergoing this very slow radioactive process. Well, the problem is if a radon 222 happens to be produced and then seep out, once it's a gas, it can seep out of the ground. And then if you happen to be breathe in to your lungs uranium 222 and it undergoes radioactive decay, you can be bombarded inside your lungs with an alpha particle, which is going to do damage. Now, if it's not very much, it shouldn't be too big of a problem, but if you have a high concentration of it, it is a problem. And the other problem is once the radon 222 undergoes radioactive decay, it keeps decaying down to polonium. Eventually, it can get to polonium 210, which is a solid. So all the other decay products after radon 222 are solids. So then that particular radioisotope is going to be stuck in your lungs, and it's going to continue to undergo radioactive decay. Polonium is an alpha emitter as well, and it has a half-life of about 140 days. Okay, and so then it will further decay to other radioisotopes, which can then continue. One radon 222 can give one alpha emission, but then the decay products further down the line can continue to emit both beta and alpha, depending on what it is. That's why it's a problem if it gets into your lungs and it undergoes decay before you have a chance to breathe it out of your lungs. Okay, and so it's found obviously from the U-238, which is in the crust of the Earth. And so what has happened, people have found, is the radon 222 can collect in basements. And the decay product, like I said, is a solid. So a lot of times people will have radon detectors in their homes if they have a basement. And if they have high levels of radon, then they just have to install ventilation systems to keep circulating the air in their basements to make sure that the radon-222 passes right out of the basement. So anyway, that's just two examples of two radioisotopes, iodine-131 and radon-222, that can cause problems. And I think you can start seeing that nuclear waste can be a problem because nuclear fuel pellets have a large amount of uranium-238, and also a fission product is iodine-131. So those are just two examples of some of the problems with the leftover fuel from spent nuclear fuel cells. So we'll talk more about that in the next video.